Alright, I just want to take some time to do more examples of solving compound inequalities now that we understand what they mean. Okay, so here's a compound inequality separated by the word or. So I need to find all the x values that make this true or this true. What we need to do is figure out what x could be over here and what x could be over here separately. So let's work on the first one. Add 7 to both sides and divide both sides by 2. So the first inequality is equivalent to saying x is less than 8. The second inequality, let's subtract 4 and divide both sides by -3. And we already know that when we divide both sides of an inequality by a negative number, the symbol here flips, right? So 7 divided by -3 is the same thing as -7/3. Alright, so now we've got this new compound inequality that's much easier to understand because we've solved each of the inequalities separately for x. Now we have to take into account this word or and put both of these together to figure out the solution to the whole thing. So x could be less than 8 or less than or equal to -7/3. So I want all the x values that make either one of these true. So -7/3 is here, 8 is here. What about numbers smaller than -7/3? We know they're going to be shaded, right? Because all those numbers make this first inequality, or the second inequality, true. In fact, -7/3 is also shaded. What about numbers between -7/3 and 8? Well, numbers bigger than -7/3 won't make this inequality true, but numbers smaller than 8 will make this inequality true. So all these numbers also have to be shaded. What about numbers bigger than 8? Numbers bigger than 8 will not make this true, and they also will not make this true. So numbers bigger than 8 don't make either one of these statements true, so I can't shade that region. I have to make one of them true at least, right? This one or this one. What about 8? Does 8 make the first statement true? 8 is not less than 8, so it doesn't make this statement true. 8 is not less than or equal to -7/3, so it does not make this statement true. So 8 is excluded from our solution. So the solution to this compound inequality is any number smaller than 8. Now we have an AND compound inequality. Let's solve each of these for x first, and then find all the x values that make this and this true. So to solve this first inequality, you have some options. I'm going to subtract x from both sides to get my x's all together. So this is -15 is less than x. Well, if -15 is less than x, then x is bigger than -15. I always recommend in inequalities getting your variable on the left side. It's much easier to interpret its meaning. Over here, I need to divide both sides by -4. That's going to give me x on the left. 0 divided by -4 is 0. But since I divided by a negative, this less than or equal to flips and becomes greater than or equal to. So now I've got this new compound inequality, right? This isn't the solution. I'm just isolating what we need to focus on now. X is bigger than -15, and x is greater than or equal to 0. I need to find all x values that make both statements true. So let's cut our number line up. Sorry about that. I want a straight line. Let's cut the number line at -15 and 0. Okay, so let's start with numbers smaller than -15. Numbers smaller than -15 do not make this first inequality true, right? Because they're not bigger than -15. So I can't shade any numbers here because I'm looking for numbers that make both statements true. Numbers bigger than -15 and less than 0, this region here, make the first inequality true, but numbers between -15 and 0 are not bigger than or equal to 0. So they don't make the second inequality true, so I cannot shade this region either. Numbers bigger than 0 are clearly bigger than -15. Numbers bigger than 0 are bigger than or equal to 0. So all the numbers here make both statements true. 0 also makes both statements true, so I need to shade it. These are all the numbers that solve it.